In this video, we are going to learn about matrices and the different properties of matrices using, say, a 2 by 2 matrix. We will also give some examples to understand the different properties of these matrices. The different operations using matrices are the equality of matrices, addition and subtraction of two matrices, scalar multiplication of matrices, zero matrix, multiplication of two matrices. First one is the equality. If we want to say that the two matrices are equal, if and only if the corresponding elements are the same. Before checking the corresponding elements, we must make sure that the orders are the same. See, the orders are given as n by n, or if it is a square matrix of order 2, maybe it is 2 by 2. In other words, it has got two rows and two columns. So two matrices, say A, B, C, D and E, F, G, H are equal, provided the corresponding elements A is equivalent to E, B is F, C is G and D is H. When we want to add or subtract two matrices, then we have to check whether the orders are the same. We have to add or subtract the corresponding elements of the matrices together. And we also know that the addition is commutative in ordinary numbers. So the same way here, addition is commutative and it is also associative. But subtraction is not commutative because 2 plus 5 is not 2 plus 5 is the same as 5 plus 2, but 2 minus 5 is not the same as 5 minus 2, and it is also not associative. So if we have two matrices, add the corresponding elements or subtract the corresponding elements if you want to add or subtract respectively. Suppose if I am multiplying each element by a scalar, then that product, whatever result we get, will be commutative because 2 times x is the same as x times 2, so it should be commutative. And this is called a scalar multiplication. You are multiplying the whole matrix x, y, z, w by just a scalar c. So each element of the matrix is multiplied by that scalar. And if all the elements of the matrix are 0, then it is a zero matrix. And it is usually known as the additive identity because if I am adding this with any matrix of order 2, it will lead you to the same matrix. A, B, C, D plus this identity zero matrix will be just the given matrix A, B, C, D. So this zero matrix is always the additive identity. If you are trying to find the matrix multiplication, first we have to check whether the number of columns of the first matrix is equal to the number of rows of the second matrix. And for this, say suppose that the first matrix is of the form m by n, the second one should be n by some s. That is, number of columns must be the same as number of rows. If these two are different, then you cannot multiply, and the ultimate product will be m order m and s. For example, see here it is a 2 by 2 matrix. This one is a 2 by 1 matrix. So the ultimate result will be a 2 by 1 matrix. You are multiplying ax plus by. So the first row here is multiplied by the column. Suppose if it is a 2 by 2 matrix and a 2 by 2 matrix, so the number of columns and rows are the same, the ultimate will be 2 by 2. So here each row is multiplied by the corresponding column here. So it is AE plus BG is my first element. First row is multiplied by first column. First row, first column. This is first row with second column. This is second row, first column. Second row with second column. So you get the elements like this. If you are taking some numerical values like this, examples, you can add the two matrices by just adding the corresponding elements. You can multiply by a constant. You can multiply this product. So here, see, the row is multiplied by each column. So 3 3s are 9, negative 2 times 2 is negative 4. Then again 3 times 1 and negative 2 times 4. So those are the two values here. So the same way with the second row, you can multiply the two rows and two columns. You get these two. So the ultimate will be a 2 by 2 matrix. If you are trying to solve a system of linear equation, say a system of linear equation in two unknowns, two variables x and y, which is 2x plus y equal to 3 and x minus 2y equal to negative 1, we can consider two matrices. One is the coefficient matrix 2 1 1 negative 2 and the unknown as the column matrix xy. The product of those two must be the coefficient matrix 3 negative 1. So in this, if you are trying to find xy using the algebra, we know that we need to find the inverse of this matrix 2 1 1 negative 2, and that has to be multiplied by 3 negative 1. We'll be learning how to find the inverse matrix, or we can also use our graphing calculator to get the inverse of a matrix. Once when it is known, we can multiply that by 3 negative 1, and that will give you the solution for this system of linear equations. So the same thing is applicable even if it has got 3 variables or 4 variables and 5 variables. You can just find the inverse of the coefficient matrix, multiply by the constant matrix. That will give you the solution. In this video, we learned about the matrices, the different operations of it, and we saw a few examples to understand the properties or the operations using matrices. Thank you for listening. Thank you for watching.